Hello everyone. I guess let's wait for 4 to 5 minutes more so that people can join and then we will start.
Okay.
Uh, Ali and Vakas, I guess we should be maximum waiting for 5 minutes. At
Okay.
3:15, we will start ultimately. I guess that
Okay.
will be great time for everyone to join. Hello everyone. I guess let's start. I hope you people can hear my voice. Uh, can someone please confirm that am I properly audible to you guys?
Yes.
Yes, you are.
Okay. So let's start. I guess last session we have also shared the recordings. Uh, and for today we have to build a churn prediction model using KNIME, and particularly we have to clear that how KNIME can be used for like a no code type strategy for building any data science model. For that, we example which we were working in last session was uh, churn prediction, and we will be now today we will implement that particular you can say that particular example end to end. So just to give you people a brief introduction, or you can say summary of the last session. uh, so the problem statement on which we were working was like churn prediction. Churn is an you consider an integral problem, or you consider a really big problem for any business who is like working in market. And then we talked about particularly an example where we will be working on an example related to churn in telecom sector. Then we discussed about predictive modeling, and from predictive modeling we jump to data science life cycle. The data science lifecycle slides. Particularly this diagram. We discussed this diagram thoroughly, and we have also discussed three different examples for understanding that how a model should be trained and what should be kept in mind. The main thing, if I can share a summary, then you should consider data science model training like training a baby for yellow and green, red cards. Then we discussed about exam all example where we tried that the people like the question we should be given by a teacher in exam all should be different from what he has covered in class using example, so that we can build a better trust on the student learning, on a student's analytical capability. Then we also discussed a law enforcement agency example for reference, and then we close this last session with crisp understanding that what is crisp and how we can map it with the different things. So the 2 day session is all about predictive modeling, and we will make our first predictive model based on the like provided data. And the data which we are using, like it was shared in last session, it has 21 column, 3300 rows, and particularly the different dates again which this data has been provided. The dates were also shared in last session. But before starting to this session, I would request everyone to please, like, you have 2 minutes. You can go through each and every um, column again, so that you can remember that whenever we will be using names of these columns, so you people have a clear idea that towards particularly which particular column I'm referring. Or so you people have 2 minutes. Please go through these columns and definitions so that all of us are aligned when we will be working on the data. You have 1 more minute to review these columns, and then we will start.
Hi, Ali.
Yes. Hi.
Your screen, I don't see column churn.
In this screen, yes, churn is something like this is a separate column where we have defined the time windows. Like you have to memorize, or you can say just keep in mind that what does it mean when I talk about area code, and this is the duration which you have to keep in mind for the churn column, right? One means the customer switched off his SIM, and zero means his SIM was in his mobile, right?
Right.
So I guess let's move forward. You people have like what seen this example. So just to summarize the thing, like the purpose of churn prediction or any predictive model is that what's the relationship between all of the information which is given with respect to historic data, all of these features, how these features are impacting this output, or we can say that what's the relationship between all of these 20 columns with this one particular column. So this is the value add of you can say that data science models or data mining models, that we can easily find the patterns behind these combinations. So coming back to KNIME, I would request everyone the data which we have shared last time, you can like create a workflow. I created a workflow with the name of PASHA underscore workshop underscore 2, and then you have to place an Excel reader and configure it for the file and open it. And once you people have done it, please type done in chat window so that I can have an idea that you people have copied or imported this data in KNIME. So whoever has done is everyone who has uploaded the data in KNIME, the provided access file, please type done in chat window so that I can have an idea that we should move forward.
Assalamu alaikum, Ali. Sorry, I joined a bit late. This is the Excel file that you shared through WhatsApp
WhatsApp last
in
week.
the last session.
Yes, yes, this is the same file.
Yes. Okay.
Please, those who have uploaded the data, there are 2-3 done. So we will wait for another 1 minute and then we will move forward. Okay, so let's move forward. If we go to our data science life cycle, the window which we have explored, like we have got some data where we have to predict churn, or we have to find the relationship between all of these 20 variables and the churn column. So if we jump back to our data science life cycle model, then there was first thing that we have identified our problem that we have, that customer churn is increasing. So how we can predict people who will be churning in future, so that we can address them on time, or we can proactively offer them something so that they retain their self on our network. Then what sort of data we are using? As I've told you, just to memorize just the names of those columns and description of those columns. We are using customer information related to how much calls he was making, how much SMS he was sending, what was his recharge pattern, how much international calls he was making, and other things. Whether he was using a voice messages plan or not. So there were roughly 18 different features, 20 different features which we were using in our data set. Uh, then now the data has been collected. EDA is a quite like vast field, and KNIME comes up with a lot of easy to use tools and nodes. First node which we really want to explore is, last time I told you about KNIME Hub. So for getting the first glimpse of our data, or you can say that the first confidence on the data, we will be importing a simple node from KNIME Hub. And import is quite easy. Like here is KNIME, and I will type here data explorer node. Here is data explorer node. I will just click it, and there will be an option drag and drop. I will drag it and drop it on my KNIME window, and the node will appear. So every one of you, please follow the same steps. Go to KNIME Hub, search this node and drag it within the KNIME editor window, and there will be a pop-up. Just let me know what sort of pop-up you have received, so that I can guide you that why this pop-up hasn't appeared and what's its purpose. So now it's your turn to replicate the things.
Ali, we need to search Data Explorer.
Yes, yes. On KNIME Hub, and as told in last session, KNIME Hub is a community place for KNIME. So if you are facing any challenge in finding any sort of information or help, or even something to find pre-built, so that you can instead of reinventing the wheel, you can reuse the work done by someone else, you can go to KNIME Hub.
Okay. So I've received a pop-up. It's saying the extension KNIME.javascript is not
Can you
expected.
please share your screen
Okay.
so that everyone can see it?
So I've shared my screen.
Okay. So first thing is that KNIME comes with a standard node repository. If you want to enhance the capability of KNIME, then you can install multiple extensions, right?
Okay.
So this Data Explorer node needs an extension installation, which is KNIME JavaScript Views Labs, right? So once you will drag anything from KNIME Hub, then the dependency will be automatically solved,
Okay.
right?
I,
So if you will click yes, just click yes. you can see it can start downloading. You can double click the smaller green bar, and it will show you the details that what's happening behind it, right? So it's asking you that to import this node, you need to install this extension.
Next. Next.
I accept.
Restart the machine or not?
Yes, yes. It will restart the KNIME only, and whenever you will install an extension, KNIME will get restarted.
Okay.
You can save it as a okay. Click it OK, because you wouldn't have an example like permissions to store the files back to example server, example workspace, because that's only read-only workspace. Or you can close it, like you can KNIME has not been restarted. You can close it and you can reopen it.
Closed it and I'll restart.
Ali, how safe is this with respect to the cybersecurity challenges? Huh?
As discussed in last session as well, like as of now, I have personally delivered more than 10 training across 9 corporate training in different telecom companies, in bankings, and one of the insurance industries. So usually these companies are quite savvy in terms of data. So their information security team approved its installation. So it's quite like you can say that this was just for the example that there is no hurdle or there is no issue that there will be any data leakage or data sharing related, information security related challenge in this tool,
Hmm.
Okay, it's
right? Now, can you please like go to 9? Sorry, you are in 9. Everyone, please come back to the screen. Let me show you another thing. If you can go to file, sorry, in 9 file, in 9, yes, in file menu, there is install KNIME extensions at the
okay.
right.
Should I click it?
Yes, click it. So there are two ways to install extensions. Number one is if you will drag and drop something from KNIME Hub, the dependent extension will be automatically get installed. If you're looking for a particular extension, you can explore the extension from here,
Okay,
right? For example,
right.
just like click expand first one, expand. Go to left side, yes, click there. So these are the sub extensions which are there. If you want to install anyone, you can click on that extension and just click next, and it will get installed.
And the one that we have just installed, it has been added here. It was
Yes,
not here in earlier. Okay.
yes. It was like it should have been there. It will be in 9 lab extensions. Go like here,
Yeah,
expand it. It was
right.
there,
Okay.
right? So there are a lot of things. Even for example, if you want to do some sort of speech analytics, then extension will be there. If you want to something, you want to work on processing, subsequent extensions will be there, then so on. So this is how like things work in KNIME. So you can expand the repository, or you can say that the list of nodes in node repositories can be further expanded by these extension installation,
Okay.
right?
So should
So
we restart the KNIME Analytics background after the installation?
yes. After installation of an extension, restart it must, because this application is written in Java, and usually Java applications need to be reloaded just to encapsulate or reload all of the changes which were made to the platform or the software. So you people have to restart it.
So Ali, I'm sharing my screen.
Sure. Let me share. So once everyone is done, please done like type done in chat window so that I can have an idea. You people have 1 to 2 minutes more to install it, then we will move forward. Only one done in chat window. 2. One more minute and then we will move forward. I hope everyone will be done by that time. Okay, so we have placed a like data explorer node, and this node is a quite like good node which gives you a summary of your. We also use a word as summary statistics, like to give you an idea that for example what sort of information is available, or you can see that what's the data distribution of your data in hand. So I will just connect it, and I will first execute it with default options, and now I will open its views. So you can see on my screen that all of the basic information related to describing as cleared from summary statistic, that how we can summarize a particular variable, all of the relevant information is there. For example, let me like select this area length code. Minimum value in this column is 1, maximum is 243, average is 101, standard deviation is 39, then variance is this 1585, skewness is this, kurtosis is this, overall sum of this, number of zeros in this data set, how many number of zeros are there, and then so on. And even the histogram or the distribution graphs for this data is also visible on right side. Here you can see. Maybe some people will be having a different view. Like for example, there will be plus. So depending upon the screen resolution, this view will adopt itself, and then all of the information which was appearing on right side of this columnar information, it has been now started to appear here. If I will further zoom in, just like we zoom in zoom out a web page, rest of the column will start to appear here, right? So if your view is different, then do not worry. So before I ask you people to replicate the thing, let me like clear one thing. Basically when we talking about data or summary statistics, we talk about two things. Number one is centrality, and second one is spread. And in centrality we talk about mean, median, and mod, while in spread we talked about range, standard deviation, and other things. So if for example there were distribution graphs, histogram graphs at the right side. So if I will draw a histogram, then for example to describe the centrality, I can see that where my maximum of data lies. This is centrality, which can be described through mean, mod, and median. While about the spread, its range, number one is range, which is like minimum and maximum value, which is minimum here, and here it's max. And then second thing is standard deviation, which uh, helps us to identify the gap between like or the spread of this distribution in terms of variance, or you consider indirectly with respect to mean. So all of this information was just populated for all of the variables in just a fraction of minutes or fraction of second. Further, you can sort it like this. If you want to sort it out, then you can sort it out here. For example, maximum number of zeros are appearing in this column, which is international plan. That, for example, if a customer has bought any international package or not, right? Then there is data for nominal values. In your data, there can be numeric values on which you can apply different like arithmetic functions like mean, mod, and sum, min, max, something like that. But nominal is the data which is textual in nature, and this data was being represented by, if we see here, where the data type was mentioned as S in the box. Here you can see, right? Because on textual data, we cannot find averages of the textual data and other things directly. There's an advanced technique names and encoding, which we usually use to find the such stuff for that data, but that's not part of today's session. But for the nominal data, the information is there, right? Secondly, it's a blue node, which means it will have views. So that's why we are going to views. Then there is nominal rate things. Then there is data preview, like sample data. All of the rows which you have are being displayed here, right? So so now it's your turn to replicate this thing. And if you people have any query, you people can ask. And the purpose of like displaying such node was that maybe something is very difficult in terms of mathematics and statistics, but it KNIME that will be just a node away, with very few information configuration, and with very you can say that almost a no code scenario is there, that you haven't wrote single line of code, but yet you have find all of the information. And even the people who are using Excel as of now, like they can share their input, that if I would have asked them that replicate same information or get same information from the provided raw Excel file using Microsoft Excel, how much time it would have been, you people would have been taken to get with the same results. Can anyone please tell? So now it's your turn to
I think that it would be taken about 2 days.
yes. So the purpose is KNIME is not only to like go with the for only for the data science, but just to like pace up your day on day data analysis task. KNIME is a really good tool.
Ali, how did you open this screen?
One thing you people have to remember is the color of the node is a blue node. Whenever it's a blue node, there will be an interactive view here.
Secondly, the name of the node in your screen is summary statistics, while
No.
I have node 2. How did you change it?
It's Data Explorer is the fixed name. The top name at the in bold format is the name, but at the bottom you can change as per your own learning. For example, here I'm going to change node 2 as read data from laptop. So it's like annotation which you can change just to make your workflow more documented.
Thank you.
So let me know when we have to move forward. Okay, now let's move forward. Like I'm just like gave you a just hint of the EDA that, for example, just a question from you guys. For example, if I would have sorted the things at number of missings, and for example, for area code, there would have been a number of 400, then what would have been your conclusion, that why, like, what should be have been your like course of action based on this number, that four, that out of 40 row, sorry, out of the, sorry, I pronounced wrong number, like we have 3300 rows, then for 3000 rows there would have been number of missing with a value of 3000. So what would have been your course of action, or what comes to your mind that why this number is high? Hello.
There would be, I would think, I would rather tend to think that there is a severe lack of information on the part of the users, on the part of our customers, that they are actually not writing the area code correctly.
You are right. In short, like you have got first hint based on Data Explorer that this column need to be revised, right? Either it should be dropped because out of 3300 customers, 3000 customers area code is not available. So which means I am trying to build my analysis or data science algorithm based on data which has a lot of missing values in it, right? So similarly, if I come here, if a standard deviation would have been 0, what does it mean?
It is perfectly, absolutely the mean result. There is no deviation from the predicted value.
Yes. You can say that it's a constant.
All values are same.
Yeah, constant. Yeah.
Yes. So in data science, the constant column doesn't have any value. In data science, these columns should be you can say that should be removed in your like next steps. So the purpose of these summary statistics is to get a first exposure of your data in a summarized way, that how your data is like what sort of data you have in hand, and what sort of error it can encapsulate in within it, so that you can quickly fix them before moving forward. So this is the purpose of EDA. There are many techniques, of course, like EDA is a complete you can say that topic, but of course, like such simple nodes can give you a lot of information about your data so that you can fix it. For example, even number of zeros, like maybe international plan is for 3300, out of them 3010 have zeros, which means they do not purchase international plans. But business wise, it makes sense that not every telecom customer is making international calls, which makes sense, right? Similarly, voice plan is there. So by just like spending 5 to 10 minutes, you will have enough information to refix your data if it's carrying any sort of abnormality or any sort of issue within it, right? So this was the Data Explorer node, and this was the like just a glimpse of the EDA. Now we will move forward to new nodes, and as of now, first I will place it here. Number to string node. I will click it, and I will change only the data type of churn column. I can select the columns here. It's a column standard column selection panel in KNIME. You can double click, you can use double arrows to move all of the columns here and there, and even you can select a single column from here. Or if you want to, for example, type filters, you can type filters here, right? So I only want to change the data type of churn, and again I will press Control and OK. And this node has been automatically executed. So now you can see that type of this churn column has been changed from 0 to 1. So before giving you time to replicate the things, I will deploy a decision tree learner here. And I will type our drop our decision trees. Predictive here. Then I will place a JavaScript module, right? And before connecting, let me first connect them. And I'm just changing the annotations. You people have also to change the annotation accordingly. Book, which teachers have to teach, right? This is classroom environment. This is exam hall environment, and this is paper checker, right? So please drag and drop these nodes, and then we will move forward and we will configure them one by one, and we will see it. Like rest of the session will revolve around only these three nodes, so that and we will discuss the configuration of particularly this node quite a lot, so that you can have an idea that what's the the real value of any data science initiative. These are the algorithms, the usage of these algorithms based on a particular data to solve a particular problem which we have in hand. For example, in our case, we will be using decision trees to find the relationship between all of the 20 columns and churn and non-churn column, right? Based on the data which we have in hand. So this is like a summary of the problem statement which we will be solving.
Mhm.
Ali, you did something in number to string. You changed data type or something. Can you repeat?
I have just changed the data type of a churn column.
Yeah, so
First
should
thing,
we do that?
sorry, your voice is distorting a lot.
I'm saying we should do that as well.
Yes.
Okay.
Who have done it, please type done in chat window. Also change the annotation so that we can use different example to refer again to nodes in a quick and easy manner. Please type done, whoever done it correctly. So 2 done. Other people please also write done in chat window.
In summary statistics mode, you did EDA glimpse. I did not do this. How should we do this?
Like it's just like annotation. Like you can type the annotation, drop the annotation, and then you can move it wherever you want.
I'll do it. Thank you.
And you can change the things as just like a Word document.
Yes, thank you.
Ali, can I share my window? I have a little problem with this.
Yes, please.
Please. This is the problem. I am going here to the number 2 string. I have executed it. I am getting this. And for
No. Okay. Yes, please.
so how do I get the data from here to select or unselect?
Okay. Can you please click on cancel?
Sorry, to what?
Cancel the dialog. At the
Cancel
bottom, on right bottom.
on the right column. It is the
Right
enforce
bottom,
include
No, right bottom. Right bottom, there is a cancel button.
this.
Yes. So number to string. Yes. Double click it now. Have you typed any filter in it?
No, I haven't.
Can you click again cancel? Go back to previous window like node 1. Check its output. Node 1 output.
Yeah.
No. It's first like you have to check this option. Your table contains column names in row number 1. Double click it. Node number 1. Here's the table name contain columns names in column header area.
The
Can
column
you
header.
can you move cursor up here?
Yes.
Bottom. Yes, there is option. Yes, here bottom at yes this one. Check this
Table
one.
contains. Yeah.
Yes.
Yes.
So now you can see here at the bottom that your all of the columns have a certain name now.
Yes.
Right. Now click OK and execute it. Execute it. Now go to number 2 string.
Okay. Now I have to select the churn.
Yes. you can use double arrow to move all of the columns toward left, because left side is exclusion, right side is inclusion. You have to only include churn column. And now you can use, by selecting churn column, you can use a single arrow button. Right.
Okay. Thank you very much.
Let me share my screen now. Okay. So now we have a data in hand where we know that, for example, if I look at this data, that this customer was you can say that this customer churned, and what was his historic pattern. For example, he was from area code 415. His account length is like how many days earlier he purchased his sim. He purchased his sim 150 days ago. He haven't sent any voicemail message, day, minutes, and so on. So for every information you can remember, you can also like compare it with the baby example where we will telling about every card and we will telling the color of that card as well. So just to replicate it, like I'm also using another node, color manager, and I will change it like this. So in color manager, what I can do, I can assign rows to each colors to each rows. So for example, here I have selected the churn column. That based on churn column, if there is 0, then that row should be highlighted with green. If there is 1, that row should be highlighted with red. So if I go here and I will check my table with colors, now you can see here the colors. I can easily see that, for example, these are the customers who have churned, and these were his statistics. These are her statistics, our usage patterns in historic data last 90 days, and the green one are the customer who haven't switched off their SIM, and these are their profiles. So you can see, you can also link it with the that baby colors example as well. That, for example, when a card will be when will be a card should be termed as green, and when a card should be termed as red, right? And these are the attributes of the cards, that how a card looks like, right? So now before moving forward, before I ask you people to replicate color manager and decision tree learning setting, as of now all of the setting I will like keep it as simple as like at default, but I will select a column here, that churn. This class column tell you that in which particular column you have encapsulated your problem, or how how a tool is going to get the knowledge that for example, where which columns contains your problem statement, or how you have marked your problem in a particular column. We also call this as a label or annotation. So I am telling this tool, or is this algorithm known as decision tree, that I want to explore churn with respect to all of the variables which are within my data, right? So I will click class column, and I will execute it, and click it execute and open views, and this will be the view which will appear in front of me. So now it's your turn to replicate this, and like get this output, and then I will explain it, and then we will play with different configuration of this decision tree learner, and we will also explore that what is this decision tree learner, and what's its value add in any of the data science life cycle.
We need to add color manager now.
Yes, yes, yes. Who have done it, please write done in chat window with color managers, like, and open its output as well, like this one at red and green type.
how did you open this screen?
Okay, let me tell you. So you can open the screen by going to Decision Tree Learner, and here's the Decision Tree view.
All right, thank you.
Everyone is done? Or you people need 1 to 2 more minutes?
Yes, done.
Okay. So we will wait for another 1 minute, then we will move forward. Okay. So let's move forward. If you look at this output, this is a glimpse of Decision Tree Learner output. Decision tree is a very well-known algorithm in data science, particularly when you have to read the relationship or you have to extract the relationship or mine the relationship between a one variable, which was churn, with respect to other variables which we have in hand, like how many calls the customer are making, how many old he is on our network, how whether he is an internet user or not, right? So it will like cross tab all of the information, and it will come up with its rule that how it can predict or how it can explore the churn of a customer, right? So there are some few terms of technology, sorry, few terms and jargons which we have to like clear before going to into detail. So that these are the information which we have done. Then there is churn, right? So how to read this information, right? So first we will read this information, we will clear some jargons, and then we will jump back to KNIME. So you have to be attentive for the next 5 to 10 minutes so that you do not miss any of the important information. Number one is it's a decision tree algorithm. It's quite famous, which is used in predictive modeling. And why it's quite famous? Just because of its visual output. Like it will explain a lot of things through its visual, where previously if we would have been using Excel, that would have been too difficult, but just because of its visual output, it makes things quite easy when it comes to understanding the relationship between churn column and rest of the 18 columns, right? So here at the top you can see that these are the total number of rows. Then out of these rows, how many rows have zero in it? Like for example, non-churners. Then we also call this as parent node. And in parent node, we are describing 100% of total data, where 14% are churners and 85% are non-churners, right? So this is just the same information which I've described through the like my digital pen. Then now we are branching our data, means we are dividing these 3300 rows into two set of rows. One rows are going on one side, and 31 and 22 are going on one side. For example, if I will add 31 to 2 plus 211, this number will come up to 33, right? So we have splitted our data. We also call this as splitting. That when customer day chart, for example, customer has consumed more than 44 USD dollars, then there are two one customers who have consumed more than 44.96 USD dollar during the daytime calls, and this describes 6.3% of your total data. I can say that 6.3% is with respect to 3300 rows, which will be equal to 211 rows, right? Then similarly, there is 93% of the data with respect to my parent node, this parent node. Then same is the number that there are 211 rows. Out of these 211 rows, 127 has churn equal to yes 1, and there is the rows who have churn is equal to 0. Further, in this data set, what's the distribution of churners and non-churners? That distribution is written here, right? We call this like division and splitting of the data as decision tree, that how we can split the data in a form based on certain variables which we have, so that we can start getting more sure about either churn behavior or not churn behavior. When we talk about surety, you can check here that here churner number jump from 85 to 88, and here churner's behavior jump from 14.5 to 6%. Like, you have to divide your data in a way that you can start cornering off churn users, those users who will churn down the road eventually, right? This technique is called decision tree algorithm, and this is quite there are other terms which we usually use as supervised learning or the classification problems. Of course, like this is not part of this explanation of this workshop, but the scene tree divide eventually your data in a way, or split your data in a way that you start getting the answer that why customers were churn, and who will be the next customers in line, right? So we also call this a divide and conquer methodology. And for example, just to reiterate the things, we have to clear few jargons here. They are quite easy. They will not take more than 1 to 2 minutes. But the purpose is, for example, if we have weather data in hand, if I tell you the weather of today, you have to predict whether a player will play the game or not, right? So we will split the data based on the condition. If the weather is sunny, then what will be the probability of playing game? If weather is overcast, then what will be the probability of playing game? If weather is rainy, then what will be the probability of playing game, right? Similarly, if we have know that what is the weather today, then what's the probability of not playing the game? Similarly, it will be applicable. And believe me, now there is only one variable, but in your case, the example where you are working, there are let's suppose 20 variables, and there is one variable. So this decision tree you are building is based on the impact of that one variable based on all of the 20 variables you have in hand. So it's like how an environment can impact a particular output. There's something which you are trying to take help from decision tree nodes, that how these nodes can help you to find the answer or find the hidden patterns which are controlling the churn behavior. So these are the terms. For example, here is another example. These are the data sets on like input. Predictors are input. This is output. You have to find the relationship between both, right? So this is the decision tree for it. Like, we call the grandparent node as a root node. Then we call this thing as splitting, when the data was being splitted. Then there is decision nodes, and there is leaf nodes. These are described in simple node. For example, this node will have child, leaf nodes have no child. We also call them as terminal nodes. From where onward, we cannot split our data further to improve the quality of churn and not churn within our data. Then there is a branch, a sub branch, and then we also call, for example, a tree may consist of multiple sub branches or sub trees. Here we can see here is one tree and here is one tree, right? So these are the simple jargons which you have to keep in mind. Then we will also like explore a new node which is known as rules table, and then we will watch a short video. Just before moving forward, like if you people have any question, just like tell me, then share your question and I will be happy to answer that question.
I don't understand on which basis this algorithm split the data. Like in the first,
Okay. Next question. Like this is the only question from your side.
yes,
Okay. We will clear it. Like next topic is the same. We have to touch base the same topic.
okay.
Anything else? Okay. So before explaining that why how it figure out that which column which how node should be splitted, let's place another node. This is rule set. The scene tree to rule set. This node. I will connect it here, and I will first like configure it with default configuration. And I will check its rules table. So there are 352 rules or 352 patterns which decision tree algorithms has figured out based on provided data, right? And how we are going to read this rule that customers who have international charge or international daytime calling payment less than 3.5 USD dollar, they have made more than 2.5 international calls, they have purchased an international plan. On customer helpline they have made less than 3.5 calls and daytime charging is greater than 44.96. It's saying that customers with such behavior, with this behavior, are going to like this is employees to zero, which means they will not churn down the road. And there are 173 such customers who have followed this pattern, this particular behavior, this behavior. And out of those 166 times, like out of 177 times, this rule was true, that that the rule which is has built that people with such behavior will not turn off their sim. There were 173 customers, and out of those 173 customers, 166 people actually didn't turn off their sim down the road, right? Then for example, here is another rule: people with international call less than 2.5 and international plan and have made less few calls on customer helpline, but their daytime charging is less than 44.96. Most probably they will switch off their sim, and there are 51 customers in my data, and out of those 51 customers, 50 all of them expected the same output, right? So this number is for how many people followed this rule, and this is the number how many have depicted the same output that employs to the that particular output, right? So this decision tree has learned so many rules based on the provided data, that how it can explain the customer behavior of churn or not churn by using combination of these columns, right? So now it's your turn to replicate the same thing, and then we will jump that how it figure out that state column is important, how it figure out that day charging is important, how it figure out that helpline calls important, how actually it reached to that conclusion. Once you are done with this output, let me know, then we will move forward. Let me know when once you people are done with it. Those people who have done, please type done in it, then we will move forward. Should we move forward?
Yes, please.
Okay. So now it's a question from you guys. What do you think that how this there were 20 columns, right? And secondly, just to to clarify that percentages, you can see here that all of the same numbers are here. Just we have added a color manager, which is like giving me a visual explanation that how, for example, this information was can be divided further based on the day charge. Then further, if I, for example, if I will expand it, then it will further split those two one rows into further information. For example, it's saying how we are going to read this the rules, that the customer who have daytime charging greater than 44 and have subscribed to a voicemail plan, then most probably they will not churn, because there are such customers with such behavior who have daytime charges greater than 44 and voicemail plan. There are 53 subscribers, and out of these 47 subscribers wouldn't show a churn, or they wouldn't turn off their SIM. Further, I can expand it like this. I can expand it till the time it will keep on expanding itself. So now you have another 1 minute to go to this window and like explore this decision tree. Here is another option where you can explore the things, or you can see that decision tree in a one glimpse. So it's now your time to explore it. You have 2 minutes to thoroughly explore this decision tree and come up with your question, that what sort of questions comes to your mind.
You know,
Let me know when you have thoroughly explored this, and then we will move forward.
I have a question. So,
Please.
uh, so on which basis it is deciding that it should take the day charge first, not the other variables first? Like it's splitting the main
Okay.
tree from the day charge, then afterwards it's creating the subtree. So why it is taking the day charge as a first splitting point?
Yeah. Okay. So we will clear this, but that approach that it has figured it out, it has tried each and every variable, then it placed it at the top, right? This is not like random placement. This is a systematic approach which is being followed by decision tree, and we will explain it like once you have explained this, that why daytime charge has appeared on the top. So our next topic is the same, that why only this column appeared at top, why not others has been appeared at the top. As of now, the hint is that that was the best splitting point, which was segregating most between non-churners and churners as compared to other columns,
Got it.
right? So should we move forward?
Yes, please.
Okay. So based on this information, like you can see that my next question was that why this day charge appeared at the top. So to clear this, we have to watch a video, and then we will like resume. Share the sound.
In this video, I'll walk you through a technique called
Can you listen to the audio and watch the video both?
Yes.
Yes.
a classification tree. A classification tree is, in this video, I'll walk you through a technique called a classification tree. A classification tree is a predictive analytics technique which is very useful when you have the following situation. You want to predict something about an item. Let's say your item is a student, and you want to predict whether or not the student will have a job offer upon graduation. You know some information about your item. For example, with the student, you know the student's university, major, GPA, and how many letters of recommendation were written for this student. And the known information is not all the same. By this, I mean GPA is measured on a 4-point scale, but the university name is a text field. So, numbers and text aren't the same. Let's take a look at our student data set. The thing we want to predict, whether the student was hired or not, is our target variable. Everything else, school name, major, GPA, and number of letters of recommendation, gets listed as an independent variable. Here's what the classification tree algorithm does. First, it starts with our entire data set. It lines up our independent variables, and one by one asks the computer, if we only use this variable, how well would it predict whether or not a student was hired? We ask, if we only use the name of the school, how well would that predict hiring of the student? It answers, a medium amount. We ask, if we only use the student's major, how well would that predict the hiring of the student? It answers, a medium amount. We ask, if we only use the student's GPA, how well would that predict hiring of a student? It answers, a lot. It says you get the best differentiation at a GPA of 3.0. Those above it tend to get hired, those below do not. If we only use the number of letters of recommendation, how well would that predict the hiring of the student? It answers, not at all. I've got to stop asking here because I've run out of independent variables. From this series of queries, we have two really useful bits of information now. First, that the best predictor of hiring is GPA. And second, that the cutoff is a GPA of 3.0. It told us what to cut and where to cut it. So now the computer will start building a tree, like this. Now we know that the single most important piece of information that predicts the hiring of a student upon graduation is the GPA. We then ask the computer, are you done, or can you branch out a little more? It says it wants to try a little bit more. So we focus first on the left-hand branch. Now, we are only going to consider the students who fit this criteria, those with a GPA at 3.0 or higher. The algorithm lines up our independent variables, and one by one asks the computer, if we only use this variable, how well would it predict whether or not a student was hired? We ask, if we only use the name of the school for everybody with a GPA of 3.0 or better, how well would that predict hiring of the student? It says a medium amount. We ask, if we only use the student's major for everybody with a GPA of 3.0 or better, how well would that predict the hiring of the student? It says a lot. You get the best differentiation if you group the majors as business, computer science, and operations management in one high likelihood grouping, and everything else, math, English, biology, etc., in the other low likelihood grouping. We ask, if we only use the student's GPA for everybody with a GPA of 3.0 or better, how well would that predict hiring of the student? It says, not much. Everybody here is above a 3.0, and there's nothing much to be gained by differentiating 3.0 from 3.5. If we only use the number of letters of recommendation for everybody with a GPA of 3.0 or better, how well would that predict the hiring of the student? It says, not at all. I stop asking here because I've run out of independent variables. This tells us what our next split should be. We should split the left-hand GPA node on the student's major. We then take our focus down to node 4. This is everybody who has a GPA of 3.0 or greater and who has a major in business, computer science, and operations management. We ask the algorithm, let's do it all again. It tells us it can't find anything more useful. We mark this leaf as a terminal leaf and say we can't break this category down anymore. You probably get the general feeling of what we're going to do now. For each node in the tree, we're going to go back to it and ask it, can we split you, or are you a terminal leaf? Our complete tree emerges. I've noted the percentages of the nodes on there and the size of each node. Now let's look at what each node in this tree is telling us. You could see at the top here, we have a designation, which is hired. That tells us most of the people in this node are hired. Next, we have a percentage split. This tells us that everyone in this node, 93% of them are hired, but 7% aren't. Remember, to get into this node, you needed a GPA of 3.0 or higher and a certain major. An unlucky 7% of students with these qualifications still didn't get a job offer in our data set. And finally, we have a head count. This tells us it's a relatively big node. 38% of our data set is here. And that is how we build and read a classification tree. To recap, we start with the target variable, what we want to predict. In this case, was the student hired? We also need to start with many independent variables, what we already know, in this case, GPA, major, and some other information. We start our tree with bucket 1, which contains everybody. The algorithm runs all the independent variables past it, asking which one gives the best differentiation between those who were hired and those who were not hired. It picks the winner. Now we know on which variable to split and at what level. For our tree, this was GPA and at 3.0. It then continues to iterate through each node on the tree, trying to split it on our independent variables, and stops when no further splits will give any improvement in classification. You can then use this classification tree as a black box model to make predictions. You could take a new student, apply the tree to the new student's information, and make a prediction about whether the student will be hired or not. Thank you for watching. Now you've seen a classification tree.
So now you people have got an idea that how we reached there and why date type charge column was appeared at the top,
Yes, sir.
Yes.
right? So just to reiterate the things, it actually, if you had 20 columns, then it had tried each and every column one by one, right? So what it was doing that, for example, it first tried day, let's suppose area code, then day charge, and then so on. This thing was done 20 times. It found out that best split of my data is day charge, right? Now the same exercise has been applied on this node, and same exercise has been deployed this time. Well, for first time it was deployed 20 times, next time it will deploy tried again for 20 times, right? To generate next splits. So you can say that ideally this operation was performed at least 20 by 20 times, means 400 times. So the purpose of any data science algorithm is to systematically find relationships. Can you imagine if you would have an Excel in hand or Excel in hand, you people could have done it?
No.
No. Or even if for example, if you people have could if people you could do it in Excel, how much time it would have taken in SQL or Excel? Like months, days, weeks,
Yeah.
right? So this is the value add of data science algorithm, that it reduce lead time. Like the thing which was previously done through a lot of effort, a lot of like manual work, algorithms automate those things, right? So coming back to this, another slide which I want to we will not take a deep dive into that thing, but just to like give you an option.
So Ali,
Yes, please.
uh, it means that the rule thing, the rule table which we saw, is the one which is deciding the trees. Right?
Yes.
Am I right?
You can, yes, you can say that every rule was a particular branch in your decision tree,
Yeah, exactly.
right?
Right.
So ideally, like this decision trees works on the entropy thing, like the just a simple example which I will explain here is, for example, there are 5 families: family 1, family 2, family 3, family 4, family 5, right? And there's a description, visual explanation that how many are cricket lovers and how many are football lovers, right? There may be some typos as well, we will figure out as well in this slide deck. For example, if I will select a random person, then the probability of getting a football lover is 50-50 and a cricket lover is 50-50, right? We call this as maximum entropy or maximum confusion, right? If I ask you that if a member from family number 1, if you will randomly select a person from family number 1, he will be a cricket lover, football lover, then you will say that there are 50% chances, and we call this step as maximum confusion point, right? If I go to family number 2, then there are more cricket lovers and less football lovers, right? So we can say that entropy has been reduced. Why entropy has been reduced? Because we have got more certain about a class. Similarly, there is another, you can see that here it will be 70%, here it will be 30%, right? So here we have more certain about football. Then similarly, if we have started to move from 4 to 5, you can see here that you have now 100% certain about a particular class, right? So we call this concept as entropy, or you can say that it's also measure of disorder, or the level of uncertainty in output. So if you jump back to that KNIME decision tree, you will see as you are moving downward, either the concentration of the red is increasing color or the concentration of green is increasing. So that's how it picks different variables. It tries to reduce the uncertainty as it will start moving towards the bottom of the nodes, or the leaf nodes, right? This is how a decision tree is built. So every variable at every step is being tested and then being designated at a particular place with a statistical reason. And the objective is that how we can increase our certainty, or how we can remove reduce uncertainty from this point onward using that particular column. For example, here it placed at the top that day charge is the variable which is like making me more confident and reducing the uncertainty at a maximum level as compared to other variables. So you can see here that's why the percentage of churn has been jumped from 14% to 60%, right? And if you will look at these numbers, such gap wouldn't you will find anywhere else. That's why this day charge variables was kept at time, right? So let's suppose now we want that for example, if there is a variable, I know maybe statistically this variable is important, but there is sometimes you have to figure out that you want to enforce something, you want a particular variable should come at the top. For example, you want that statistically state is a very weak variable, but from law enforcement point of view, from a campaign designing point of view, state or location is the most important variable which usually drive my business. Maybe statistically it's not important, but from actionability point of view it's really important for me. So I will enforce it using this root script node. I will click it OK, and I will execute it. So now you can see that state column has appeared at the top. And I can see here, for example, if I will keep on expanding the things, let's see if any state is behaving different, or let's suppose here is the state which is Los Angeles. Here day charge minutes are not important, but customer helplines are more important at second level, right? Then there is helpline like Los Angeles, WV state, IN. Here is a state where evening calls are more important, right? So this is how like you can further enforce your things. Even if you see that now this decision tree has become too big, maybe it will become difficult for me to encapsulate the things. There are options that I want only 2 branches at every step, so I can click it here, binary nominal options. Now you can see that instead of for every state there will be a new node, it has made the groups, and for this group daytime charges are important, for this as well daytime charges are important. But let me, like, let's suppose try the second layer. Again, the voicemail plan is more important here. Customer helpline, this is how we further, like, tweak, or you can say that customize these configurations so that we can get inside the required insight which are actually actionable for us, right? So now you have 5 minutes to perform the same configuration. Just explore these nodes and come up with your questions, then we will move forward. You have 3 more minutes to explore the decision tree configuration. Just try it different, like all of the root split and other options, so that you can have an idea that although these algorithms are statistically driven, but still you can give your input based on your own need. Like one of the examples which I gave you, that usually marketing campaigns are location driven, so you can assign state information that um, that, for example, location is important for me, so split the things at location. Then you have seen a new insight that for Los Angeles, instead of daytime charging, actually the way the information which varies for that important for that state is, you can see, what you can see is that customer charge minutes, or sorry, helpline calls for complaints is more important. You people have 2 more minutes to explore the things.
Ali, can you please show the main screen of KNIME?
Let Should we move forward? You people need 1 to 2 more minutes to explore the things. Hello guys. Should we move forward?
Yes, Ali, we can move.
So the purpose was that these algorithms, there are many algorithms which you can try, like here in analytics, here in mining. You can see here that a big list of algorithms exist here, like Bayes, knife Bayes classifier is there, decision trees, different decision tree variants are there, decision tree learners, random forest is one of the very good, like you can say that very widely used algorithm in data science. So there are many things which you can like use in your data set. But the point is to clarify is that Python and R are just like one of the ways to do data science. There are other options as well. So coming back to this point, let's play with other configuration, one another configuration. If I will keep it exploring it, yes. Let's jump to this node. How many customers are there in this node?
2.
Okay. So can you design an offer which is only like being designed for 2? Is it financially viable? No, right? So maybe this decision tree is finding a lot of things, but yet it's coming with a lot of too much information. Like too much information and too less information both are dangerous. We have to find something between. So in KNIME, we have option here that do not make a node if it has less than 50 customers in it. Right now you will see that your decision tree has been shrinked a lot. As soon as it will start seeing less than 50 customers, it will stop itself. We call this step as pruning, just like cutting your tree in your garden. This is like that, right? And yes, and even the other thing which you have to observe when you have shrink your tree, the number of rules will also decrease. For example, previously we were having 352 rules. Now it has come up with only 11 rules. But you can just like see the power of an algorithm, that there was no complex mathematics which you have to remember. There is nothing else you have to remember. It's just the configuration and the output. You need to learn that how you can interpret that information, right? For example, this rule is applicable on 13 rows and then 22 rows. So so you can also like read explore this, but before I ask you people to explore it, now next point, the next really big problem is that for example, can we trust these rules? Like how we can build a trust on decision tree algorithm output, that if the output will be like trustworthy and we should like build our strategy on those insights or not, right? That's why a new term comes up. We call this at confusion matrix, right? It's like if you go here, there is a predicted, like it's an exam hall environment. So I will click it, change prediction column name as prediction column. It's like apply those rules which you have learned in node number 9 to the data which I'm providing you through color manager, and fill your output in this particular column, prediction column. So if I will execute it, then you can see here that a new column will appear at the end, the prediction column. This was the actual answer. This is predicted based on the rules which it has learned, right? It has applied those rules and figure out the answer, which was like here, that if a customer, based on these rules which are visible here. So now it's your turn to configure this predictor node and exam all and populate this prediction churn column.
Ali, sorry, you'll have to repeat. I just forgot. How did we get?
Sorry, this one, the prediction column.
Yeah.
So here's the predictor column. Now what we predictor node, what we are trying to do is that all of the rules which were learned by a decision tree learner node, which where description of those nodes was available in node number 9. What I'm trying to say that apply those rules on the data set which is I'm providing you through node number 8, and give me final results and write your answer in this column.
Okay. So we don't have to do anything. We just have to execute.
Yes. Because if you come to my screen, those like blue nodes connectivity is showing the same, that I am passing those learned rules to a new node and passing a new data set, and this predictor node's job is to apply those rules on the provided data.
That means
Ali, what was the difference between those black triangles and squares? You told, but I forgot.
Like for example, this rectangle, black rectangle means there are rows and columns being transported, right? Then this for example, blue square means that these PMML, there's a term known as PMML. So if I will take it here, then it will show me it's a decision tree model or PMM model is being transported to next node. Here if I see, you can see it here that it will be showing as a data table, right? Table with clear colors. So you can see that what sort of output is being transported to next node as an input.
Oh, thank you.
Should we move forward?
yes.
Okay. So now you can see here that it's like this was the student I have gave him a paper to solve, and he has solved it, and his answers are now available in predicted. The actual answer behind the book and the answer which it has written in exam hall is there, right? So now you can see I can compare it directly whether this particular prediction was correct or right, or how many predictions were correct and how many predictions were wrong, right? Or how many times a student solved the question properly with right answer, and how many times student wasn't able to solve the question. Do you agree with this point?
Ali, I thought the column churn is the data and the predicted prediction column is the system telling us that it should the output will be this. But
Yes.
you're saying this, but it seems like what you are saying that churn column is the right answer and predictor is just the prediction.
Right, you're right. Like it's like this churn column is the data which we already in hand, right? Which we already know that this customer will churn, right? And this customer will not churn. That's how being represented by true. Like based on the actual data which we have, this output is being recalculated through the rules which this decision tree learner had learned,
Okay.
right? So it's like this is the question. These are all the columns are part of question. This is the answer which is written behind the book, right? But teacher haven't
Yeah.
given him during the exam hall, so he
Yeah.
has solved it, and he has solved it with zero example, right?
But
Now
yeah.
there will be a someone who can check it, like for example, that if I gave him 3300 questions to solve, how many times it has solved it right, and how many times it has solved it wrong.
Yeah. But what's the point of then prediction column if we
Okay.
already know the answer?
No. But the purpose is that can we trust these in outputs? Like how we can
Okay.
trust these are rules? Like by looking at these rules, it's like in data science, ultimately everything should be driven with a systematic approach, right? So now we are moving towards Coral Node, which is a systematic approach to validate the learning of a particular algorithm in data science. Okay.
So we'll see whether it predicted like how many 90% was correct or 99 or 100, and we will be able to trust the model. Okay.
Yes, you're right. So it's like here's the actual column. If I go to this configuration, if I will go to this column, here I'm going to select that here's the actual answer and here's the predicted. Now show me its result report. You can say just like a school where we will receive a report card. So here is the report card that how accurately it actually was able to predict the output correctly. It was able to predict the output 80.45 times correctly.
88.
Right? For the 12% of rows, it was not able to predict it correctly. Then there is something we call this report as confused matrix report, and there are 4 different combinations. Like if you will add, for example, all of these numbers, these will come up back to 3300 rows. But what are these numbers? Let's like have a quick video, see a quick video, and then we will jump back there.
Basically, we did a test like the guy did in that video of drinking water. He tests how many times it gives the right answer and then
Yes,
fix it later.
yes.
These days, you hear a lot about
Can you say, like see the video and listen the audio properly?
Yes.
Yes.
These days, you hear a lot about predictive analytics. Give it just a few bits of information, computers can make all sorts of predictions about you. Everything from how you'll vote, to how much you might spend on a Hawaiian vacation package, to whether you'll get a job after graduation. But how do you know if the prediction is good and if it's better than random chance? What if you have two competing models? How can you tell which one is better? There are some simple methods we use to determine how good any prediction tool is. Today, we'll take a look at two of these methods, a classification confusion matrix and the lift. Predictive analytics means we're using some variables to predict one other variable. We call the thing we want to predict our dependent variable or target variable. Some examples of target variables are how likely you are to vote for candidate X, how likely you are to buy a Hawaiian vacation package, or how likely you are to be hired upon graduation. We call the things we use to make our predictions our independent variables. Generally speaking, when we build predictive analytics models, we start off with a kitchen sink model and throw in as many independent variables as we can, and let the model tell us which variables are actually helpful predictors. Here, we show our target variable on the left. In this case, it's the likelihood of being hired. On the right, we've got our independent variables lined up, the GPA, major, and university name. I'll walk you through our favorite predictive analytics example here, how likely a student is to be hired after graduation. For standard predictive analytics work, we follow this work plan. Start with the whole data set of answers. In this case, it involves our target variable, whether or not the student was hired. It also contains the relevant independent variable information. Here, we see our entire data set. For our first student, record ID number 1, we see she went to State U, majored in math, had a GPA of 3.2, had 4 letters of recommendation, and was hired after graduation. We randomly split our data set into a train and a test set. We often use 70% train, 30% test as the split. Here, you could see our first student was randomly assigned to the test data set, while students 2, 3, and 4 were put into our training set. We tuck our test data set away for safekeeping. Don't peek at it for a while. So now our data set looks like this. You could see it's comprised only of our trained students. Number 4, we build a predictive model using our trained data set. Our model functions a little bit like a black box. We put all our independent variables into it, and out pops a prediction of hired or not hired. We then remember our test data set. We take our model and put each row in our test data set into the little black box and write down what the prediction is. We already had the record ID, independent variables, and target variable, and we're only including those records in the test data set. Here, you could see we're adding one more column to our testing data set, which is the prediction our model made. For record ID number 1, the model predicted our student would be hired. For record ID number 6, it predicted the student would be not hired. Finally, we compare the actual results to what our model predicted. In this case, we could see we were correct for students 1 and 5, but not for student 6. This model is predicting correctly 2/3 of the time on our very limited data set here. Now we're in good shape to determine how well our model performed. There are 2 measures I'm covering today, a classification confusion matrix and the lift. Let's start with the classification confusion matrix. Sometimes this is also called an error matrix. How do we make one? We put the results of our test into a table and call it a matrix. Let's say we had 100 students in our test database, and our full results look like this. On the left, we have our actual results. On the top, we have our predictions. This tells us that we predicted a total of 70 students would be hired, of whom 65 students were actually hired, and 5 were erroneously classified as not hired. This tells us that we predicted a total of 30 students would be not hired, of whom 22 were actually not hired, and 8 were erroneously classified as hired. Overall, this model got it right quite a bit. 65 hires correctly classified, and 22 non-hires correctly classified, for a total of 87% correct. This is very high. But sometimes even this matrix is a bit too much. People often like to have one single number to compare. While I will certainly caution you that these models can be complicated, and it's definitely possible to oversimplify and miss important bits, boiling it all down to one glorious number can be helpful. This is where lift comes into play. Lift is a measure of how much better our model is than chance alone. If we had no model at all, we would just assume every student would be hired. And for this data set, we would be right 73% of the time. Our model does better. It is right 87% of the time. We are 87 divided by 73 equals 1.19, or about 19% better than chance alone. This number is called the lift of a model. A model with a lift of less than 1 is worse than random chance. Don't use this one. A model which is no better and no worse than chance alone has a lift of exactly 1. A model with a lift greater than 1 is performing better than chance alone. Let's recap. We've shown how predictive analytics is a technique used when we know several pieces of information, our independent variables, and want to use them to predict a target variable, our dependent variable. For our hired after graduation example, we know the student's school, major, GPA, and number of recommendations. I want to predict if the student is hired after graduation. We start with a full data set of all sorts of possible independent variables, the kitchen sink, and also the known outcome of each student, hired or not. We split our data set into a 70% training set and a 30% testing set. We use the trained data set to build a predictive model, a little black box. We apply our predictive classification rules to our testing data. Because we already know the answer, hired or not hired, in our testing data, we can then grade our own exam and determine how well our model worked. We can measure how well we did. Two common measures are the classification confusion matrix. It told us we got 87% correct, and lift. Our lift was 1.19 or 19% better than chance alone. Thank you for watching.
So
These days,
just give me a second, please. So the purpose to show this video was that on one side we were talking about like overall accuracy of the model, but the other point in this was, for example, like which of the prediction, whether it's weak in predicting the churners, whether it's weak in predicting the non-churners. We call these terms as true positive, false positive, and something like that. Or if you want to read it, like it means that how many times is predicted 0, non-churnal was 27 3 times, and actual result was also 0, right? Then, for example, for 115 times, it predicted that customer will switch off his SIM, but eventually it didn't, and actually it didn't. Similarly, there were 213 customer for which it predicted that customer will churn, and actually it made a churn, right? So this is how like this accuracy is being built up, and we call this as a confusion matrix, where we try to compare like what is the algorithm prediction versus what's the actual value, right? So it's like apple to apple comparison. For example, if we had a data where we want to check, like for example a customer was playing and what was the prediction, if we compare it, then we can make 4 combinations. How we can make 4 combination? For example, what is the actual value? Here is the actual value, and what is the predicted value? Here you can see we called it as a true positive, as a TP term. How we are calling it as a positive? That is predicted it as a 1, and it was a valid prediction, right? Here it was a false positive. It predicted as 1, but it was an invalid prediction, a wrong prediction. So if I will jump here, then I can make 4 different combinations, right? For true negative, false negative, true positive, false negative, right? For example, just in your case, nowadays, recently people who went through COVID, didn't have a symptom, and they had a test, and test came positive, right? And within 48 hours they again had a test, it was negative. This happened with a lot of my friends who were particularly traveling abroad. So how, what sort of prediction it can be? It's a true positive, true negative, false negative, false positive. Hello guys. It's a false positive scenario, it's a true positive scenario, it's a false negative scenario, or false positive scenario.
If he doesn't have
False negative.
Others, please share your input. Like, it will be a false positive, false negative, true positive, true negative.
false positive,
Why it's false positive?
because he didn't have COVID, but the test came positive.
Yes, it's like it was a wrong alarm, right?
Yeah.
Test predicted on that it has COVID, but actually it was a wrong. So that's why we are calling it as false positive, right?
Right.
So moving forward, there are other things as well which are associated with this, like report card, which we are talking about.
Ali cannot hear anything.
Can you hear me now?
Yeah, no, yes.
Okay. So I was saying that a scorecard, a scorer node which you will looking at, is just the description of these, all of the formulas. We will not take a deep dive into these, but ultimately everything is just like written here in report card. So it's like while you will be learning data science algorithms, you have to learn about these validation methods as well, right? So let me before moving forward, now first explore this output of explorer node, and then we will move forward towards 9. So repopulate this report at your end, and then we will see, then we will move forward.
Ali, I've executed the scorer, but how will this report open?
It's being opened through, like, you will, once it's green you will click it and it will be here.
Ali, I have a question here.
Hello. Yes, please.
In the video, we saw that we have split our whole data set in 70 and 30%. 30% was the testing data set. Here
Yes.
we have performed that step,
No,
or we
no.
have skipped.
Next topic is we have to cover the splitting.
Okay, okay.
Ali, when I open this or click that option, it's showing different thing to me.
Okay. Direct numbers are different, right?
Not the numbers, the layout is different. It's like
Okay.
a table,
Okay.
not a report.
First check is that you opened Scorer JavaScript node or plain
Uh,
plain Scorer node.
Plain store. I have plain store.
Okay. You have to open it JavaScript node because JavaScripts are nodes are more visual, have more visual output.
Okay.
Ali, can you please once again show? It's not opening on mine.
It's like right click here and then
Yes.
interactive.
It gives different outlook, uh, layout,
Okay. So
tables.
first thing you have to check it that you have also placed Scorer JavaScript node.
Yes, Scorer JavaScript.
Okay. Can you please like share your screen?
Okay.
Have you found this like today's session quite interesting? Yeah, or it was boring?
It's quite interesting. Can you share? Can you see my screen?
No, still not. Now it's yes. Please right click it, and there is interactive view at the middle of the menu.
This one?
Yes,
Okay.
right.
Thank you.
The numbers are different in my report. You were right.
Okay. Numbers will be different because maybe you have followed a different configuration there, and I'm following a different configuration. Right.
So basically, there are many nodes built in this KNIME tool, and we have to use particular specific tool as per the task in hand, as
Yes,
per the
yes,
data we have,
yes,
and that
yes,
we know after using one by one.
yes, yes. You're right. Like the purpose is this like the myth of Python and R is just like a myth. You do not need to learn about Python and R. You can do a quick data mining, data science related initiatives using KNIME.
Basically, programming is already done behind these all the nodes.
Yes, yes.
Okay. So where can we look for more usage of more nodes? Like there are many nodes.
Right. It depends upon, like, you can figure out some. I've told about nine self-paced courses. You can start following them. We also offer 8 weeks extensive training on KNIME as well, so you can opt to that as well. Or like you, our third option is that you can find some book and you can keep on following that book. So there can be many options which you can start with. But ultimately, like, if you will like start using KNIME on day basis, eventually to solve your problems, day on day, hand in hand problems, that will be the best approach, and you will learn with time. But believe me, like, learning this KNIME tool is not a job of more than a week.
It's very user friendly.
Yes. And I'm really surprised by the stability of this tool. Like, it's really stable. Usually open source tools are not stable.
It reminds me of Tableau when I use it after Power BI.
Yes.
Tableau
Sorry,
is so user. Tableau is also very user friendly.
but that's a paid, like,
Then
enterprise tool.
yes, that's a bit.
This is I'm talking about like open source tools, like when it
Yes,
comes to open
yes.
source arena. Um. So then now let's move forward. One thing which we have missed is like this confuse metric thing. Now let me, like, here's something which where I have, let's suppose, have not used partitioning node. Let's see, like, how giving different example to a student in class and different example to exam, or how it accuracy gets impacted. And you can also copy paste it, like, let me, this is a scenario where teacher is giving same examples to students in classroom and in exam hall. Here I can, right, and here I'm typing it like this, like, teacher divided book into classroom and exam hall environment, right? So here's a simple configuration. Like, I want to, let's suppose, relatively divide my data set into 70% of the things, relative percentage, and randomly distribute your data set into two parts. That's why there are two ports. 70% of the data will go to upper port and 30% of the data will go to lower port. I've executed it. Now you can see that you can divide the count, that 20 out of 3300 rows, 2300 rows has been to move to upper port, and this count has been 1000 rows has been removed to move to lower port. And then simply I will execute it. Here's the answer with you can see that by 70-30 split on left side, and on right side, can someone tell me why accuracy has been dropped? Hello.
No idea.
I think the data is compromised now. The randomness of data is curtailed. A certain portion without any classification has been diverted to one side, and other data is diverted to other algorithm. So the data integrity is compromised.
Okay. What if I say, what if I
30
say, yes, please go ahead.
This 30% of data was new to this random R algorithm. It hasn't seen that before, and it wasn't trained. It hasn't trained Celgo on that testing data. That was 30%. So it was relatively new. So I guess that's the reason.
Yes, you can say that you're right. Like it's not like compromise of the data across both the samples. It's like that, the model analytical capability is now being tested truly in second phase, where we divided our data set into 30 and 70 and 30% split, right? Where a new, as soon as a student was exposed to new questions, like topic is same, that's churn or not churn, but the questions are different, right? Which is has not solved previously. So it has decreased its accuracy, but this number is more trustworthy as compared to this one, because now I can see if I will give him unseen data, then it will show me an accuracy of 86%, right? Hello guys.
Yes, but Ali, does it mean if we increase the data accuracy will keep dropping?
It can, it depends upon that how much data. For example, it's like if you a student was supposed to solve the maths question, and if you will give him chemistry question, then definitely the marks will be low, right? So it's like we
Yeah.
are keeping in mind that this is a hint. Like for example, we will be running such tests frequently, that the test feedback loop, we will running this stuff frequently, so that we can have a keep an eye on this. That for example, you can set a threshold that whenever its accuracy will drop to 70%, then it means it's time to retrain the model,
Oh, yeah.
right? Which means that patterns are the rules has been got obsoleted. They became obsolete.
How will we retrain in this scenario?
Again, like if it was trained on 2014 data, then you will start using recent data. Like you can train it on 2019 data, and you can add more variables, and then things will go on, right? Any question?
Just show the screen again where you 70-30 designated. You just changed 17, right? Only.
Like it's a relative percentage. Like if you want to divide data set into absolute numbers, you can do the rows. This will be in percentages, and I am
Oh,
distributing the data randomly.
okay.
Should we move forward?
Yes.
Okay. So as of now tell me like the where we started yesterday session that Python and R can be a good you can say that tools to do the things, but data science like there's a you can say that the workshop was starting a major perception which was it's like the previous method and that Python and R are only tools to do data science, right? This is a myth. Like you can say that Python and R are one of the tools to do data science, right? And secondly, doing it while using no code, like if you are a new learner, newbies, I would recommend that you should divide your journey into two steps. If you are from CS background, then do data science using KNIME so that you can learn algorithms first, because algorithms are common, right? The CNT here in KNIME will have same input and output if it's been implemented in Python and R. Then jump to Python R. Here, because this algorithm is something which you have do not need to learn again in step number 2, right? Then you will be focused on only learning Python and R. So that's most of the people why they fail in data science journey, because they start trying to learn Python and algorithms in one go. That's why they make their learning journey too complex, which becomes a lot of demotivation after a few weeks or few months. So if you will divide it into two steps, then things will easy. Like if you will be following this approach for 1 year, then your chances of getting a data science job or making a data science team within under you will be just too much output will be, you can see that too less chances of output. Here same thing, 1 year, but the chances will be high, quite high, because you have distributed your journey into easy steps. So we usually recommend this way, that first start your journey with the no code tool and clear the complexity of algorithms and then jump to Python and R, right? So this was the partitioning node. Then there is something like, let's see, here is another example. You can see that this person has built an employee churn prediction, that when an employee will leave. Here you can see that it's quite easy. It will just start placing its numbers, will do some sort of visualization, then it will train the model and it will validate it easily. Here you can see that it has made it in Tableau dashboard. Like it's not a visualization tool, so it has took a help from Tableau. And other article, if I there is another article where it has developed a employee churn prediction. So it's installing some extensions. Then there is KNIME workflow. It has created a workflow. Then it placed a CSV reader, and again it's doing the annotation. Now at least while reading this article, nothing is new for you guys now. It has set the joining criteria.
Mm.
Column selection is here. If you have data, and that was the first time, like it's not like building a first data science model using the no code data science tool is nothing a job of more than 15 to 20 minutes. Then you can see it's model training. It's going to use the CNT learner, same configuration. Now there is a split, like it has found out that my if my employees have a, let's suppose you can say uh, experience of greater than 1.5 years, they are less prone towards making putting a resign. But if my employees have recently joined, then they are more prone towards resignation, right? Further, it can explore it further. Then there's an age factor. Then there is monthly income factor, which is like forcing people to take a decision across resignation. Then there is a predictor. Then there is like that same confluent matrix, and here is the confluent. Like these no code tools has nothing to you can see um, do with these things. Like ultimately these algorithms, if it have been R, then it's instead of like doing this configuration in a drag and drop tool, that would have been a coding, few lines of code. So that's it for the session. And one thing which I really want to like share with you guys, that we were talking about yesterday about upskilling. So if as of now, if you want to work in data domain, first thing is like Excel is a tool which usually people use a lot. Then there is Power BI or W or MSTR, and then there are tools like KNIME or Python and R, right? So this is like skilling triangle which you have to focus. And another thing which I want to highlight is that we have a 08 weeks long citizen data science training, which I guess will be now offered in October. So if you want to upskill your skill set, then you have to refer to this triangle if you really want to remain relevant in data analytics domain. So if you people have any question, you people can ask. Like and today pace was a little bit good, but that was the content we were targeting throughout the session, and we have completed our content as of now.
Can you briefly explain what in Excel should be focused? Like
In
if
Excel, like
average.
like basic something like pivot tables, VLOOKUPs, and something about formulas. That will be a good start to get a first exposure towards number crunching.
Ali, thank you very much. It was a wonderful session. Regarding this 8-week training, will it include Power BI as well or just KNIME?
No, nine. Like we have a separate training for nine. All of the trainings which we are offering. If you go here, then these are the different trainings which are available here.
I
So all
see.
of the trainings are there, right? So you can pick and choose your trainings accordingly. But Power BI, we have a separate 4 weeks track where we offer Power BI trainings.
Ali, what do you prefer between Power BI and Tableau, and why? Apart from
Frankly,
the free and paid tool.
frankly speaking, Tableau is a leader in visualization, right? Power BI is for SMEs. So it depends upon like need of the hour or what sort of data, size of data, the reports you have in hand. Both tools can be used interchangeably. But there is another tool like MSTR. If you are working on an enterprise where you have a lot of different problems, then you can go to explore MicroStrategy. Even we have a one YouTube. So Power BI and Tableau differentiation is quite difficult because both are at the end of the day visualization tools. But MicroStrategy is an enterprise analytics tool that can be like used in a different scenarios. But the main difference I see is that no doubt Tableau is a leader in visualization.
I have read somewhere that Tableau is 80% visualization and Power BI is 20% visualization.
Yes,
So is it exaggerated or it's really 20 and 80?
yes, it's right. Like when it comes to a pure visualization, pure dashboarding, then Tableau is leader. Like you cannot match its visualization capabilities. Like the aesthetics, the type of graphs and other things, that's really like um, top of the notch. I was saying that if you go to Dice Analytics page, then there is a free data literacy training. There is a complete webinar series. Here you can explore different pillars of data analytics by one. I would recommend if you people have time, watch them one by one so that you can have a like introduction of all of the pillars of the data science. But there is a special session on MicroStrategy only. You can explore it as well to have an idea. Right?
Ali, one more question.
Yes,
Uh,
please.
for someone who's like average in Excel, even above average in Excel, and knows how to use Tableau, uh, so can that person shift directly to KNIME or
Yes,
Python?
yes, yes.
But not much of Tableau, but there's just like the how we use KNIME. We know
Uh,
the navigation and know the tools. How do they work?
uh, uh, I told you that Python and R, I'm not discouraging them, right? If you can handle, if you are from coding background, right, and you can handle you have time to handle the complexity of learning, of algorithms learning and Python learning, then you can start with Python. The only thing why we recommend to divide your learning curve into two parts, that first learn algorithms through drag and drop tool and then jump to KNIME, then it will keep you engaged and motivated throughout the learning journey. That's the value add of drag and drop tools.
Okay, thank you.
Any other question? No question. Okay guys, then let me also share the detailed outline of our 9 track in group for your reference. let me open it here as well.
Okay, thank you, Ali. Can we get the copy of your presentation?
Yes, I will share in the group.
Okay.
Just give me a second, please. Like, just for 1 more minute. Then we will sign off.
Are you interested in graph databases but don't know?
Like, here's the complete outline of our 8 weeks training I've shared in the group. Like, there are different things which we will cover during our session, the 8 weeks extensive workshop. So if you want to have an idea that what sort of topics, being a data scientist, you have to look, so it can be a good starting point. Even this document can be used if you want to learn it through internet. The only value add, like institutes or organization like DICE Analytics can add in, is just to shorten your learning journey. If you would be doing it at yourself, you would be spending 6 months. We will be helping you to grasp same knowledge in 8 months. It's like nothing more than type saving, because it's everything is publicly available, and everything is available. So we just like provide a less hurdle, or less, you can say that, less bumpy road towards learning, towards equipping yourself. So that's it from our side. So if you have any question, I'm online for 1 to 2 more minutes. Otherwise, if a person want to like sign out, he can sign out.
How
all
many?
the
Yeah, go ahead.
all these trainings will be on Zoom, or it can be done in person?
Like, as of now, due to COVID, we do not have any, you can say that, on-site training, because due to COVID, even recently to yesterday, Punjab issued a new guidelines where they have implemented guidelines. So as of now, we are doing it online, but down the road, there will be physical. But at least I guess the way COVID is going on in 2021, there will be no physical class. So we will have Zoom classes, where you have seen the interactivity, that how interactive we remain throughout the session. So recordings will be provided. We have an LMS where everything being will be organized through an LMS. You will get the recordings, you will get the assignments, you have to submit it. You will, even for example, in our training, there are total 3 people who are conducting the training. One is main trainer, and then 2 are the TAs. So they give extra time. If you are facing any problem after class, then they can come online and they can support you to fix your issues.
Okay, great.
But if
Thank
it's a
you.
corporate training for a team of people, then it can be physically done in your venue.
Okay. All right. Thank you, Ali.
Thank you, Ali. Thank you very much for a wonderful session lasting for about 7-8 hours.
No,
Thank you.
thanks for being here.
Our compliments.
Okay. So I can be approached on LinkedIn as well. I can be approached on WhatsApp. So you people can save my number, and inshallah see you again if there will be a
Inshallah. Looking forward. Thank you.
Okay.
Assalamu alaikum to all. Thank you.
Thank you. So I hope there is no question. So I will also be signing off. So thanks everyone. Thanks for being here, and see you again inshallah. This recording will also be shared through YouTube, and you people can watch it as per ease. Okay, take care, and Allah Hafiz.